Hi folks, welcome to IEE475, Simulating Stochastic Systems. My name is Ted Pavlic. I'm an assistant professor here at Arizona State University. And today I'm here to outline the course policies for 475, as well as the basic structure of the course. Now, most of the information that I say here is going to be encoded pretty well in this slide deck, which you can download from the Canvas site. But even more important from the Canvas site is the syllabus. The syllabus goes into much more detail about the course policies and the course structure. A lot of common questions that come up about the course should already be answered in the syllabus, and so I definitely recommend that you take a look at that syllabus. With regard to Canvas, there are a couple of other sections that you should pay attention to as you get used to navigating this course. Most everything can be found underneath the Modules section inside Canvas. There's a course information module that has the syllabus as well as information about the instructor's contact information, TA contact information, office hours, and so on. There's a module on the final project, which I won't go into great detail, but I'll introduce very briefly in this slide deck. There are all of the units that contain kind of the main technical content of the course, and also a special module for labs just to make it quicker to find the labs. The labs are also integrated into the units. There also are a couple of sections for the midterm and final, which will include exam preparation materials to help you study for those things. Along with the modules, there's assignments. Now, most all of the assignments will also be in the module somewhere, but if you need a quick way to find the assignments, you can go to the assignments section. There's also a grades section where you can find your grades as they're scored, and then there's the syllabus link. All of those are on the left-hand side, those modules, assignments, grades, and syllabus, and so they should be easy to find there, but they can be found at other places as well. Now, moving on to the structure of the course, every week you'll have 2 75-minute lectures and 1 150-minute laboratory. The laboratories will typically be run by the TA, although the instructor may pop by periodically to check in on things. Depending on whether there's a grader assigned to the course, the lab TAs may also assist with grading the lecture-based assignments. So potentially your lab TA could be handling all of the grades for you in particular. As 475 tends to be a big class, to make emails more effective, we ask that you prefix your subject with IEE475, like some of these example subjects that we have here on the screen, like IEE475, excuse absence due to sickness, etc., etc. Doing that helps us spot these emails quicker and even in an automated way so that we can make sure to get back to you in a timely fashion. Otherwise, they might get lost or severely delayed. If you send an email about the lab, you should always email your lab TA and possibly carbon copy the instructor. If you email the instructor about a lab issue, and the instructor doesn't know a lot about what has been going on in that particular lab, the instructor is always going to consult with the lab TA and get them involved. And so it's better just to start by emailing the lab TA, who probably knows more than the instructor does about the fine-grained details of any particular snafu that might have occurred during your lab section. When you do send an email about the lab, though, make sure to include your lab section. We can have multiple lab sections, each of them with lots of students, and so when you email and all we have is your name, sometimes it can be difficult for us to find your lab section and get to the issue that you're bringing up. Alright, so let's get to the course in general. The objective of this course will be to make it so that you have the ability to identify, model, and analyze so-called stochastic systems using a computer simulation framework. Now, these three words, stochastic, system, and simulation, are a bit loaded at the moment, but by the time you get to maybe the end of next week or the end of Unit A, those should be defined and you should kind of understand what's going on here. The outcomes for these things is we want you to be able to look at the world around you and identify systems that are best modeled with computer simulation as opposed to other methods. And once you do that, be able to build a simulation model in a selected high-level language. This particular course will make heavy use of a language called Arena. We also will make use of a couple other things, upper tools like NetLogo and Microsoft Excel, but those are mainly meant to introduce how to use those tools. The main bulk of the course will be done in Arena. Arena has plenty of competitors out there, and you're welcome to use those on your own projects, capstone projects, and so on. And in some cases, we'll even let you use them for the final project if you get prior approval. But I wouldn't view this as a class on Arena. We just happen to use Arena, but as a class on stochastic simulation in general. And with that, things like determining your input data requirements, that's going to apply regardless of which language you're using, Arena or FlexSim or Simio or whatever. Interpreting output data and making statistical statements about the performance, those also will apply regardless of which simulation platform you're using. And then communicating results effectively with written reports, that happens after the simulation. So those are all the things we're hoping to get you to gain here. So we're not, again, it's not meant to be viewed as a programming course focused on one particular language like Arena. It's meant to be focused on this methodology of using stochastic simulations to do operations research and effective industrial engineering. The outline of the topics is as such. We're going to start with an introduction to modeling and simulation modeling and gradually then build upon that, introducing then discrete event systems, the different simulation types, how we involve probabilistic modeling that you've seen in some of your previous courses, how we actually generate random numbers that are used in these simulations. Then we'll have a midterm over all of those topics. And then we continue on and we move from sort of the beginning part of the course was sort of focused on modeling. And the last part of the course is really focused on statistics. It's focused on inference. And so that will be, how do we choose, and we'll find out what this term input modeling means actually as early as in Unit A, but how do we choose the probabilistic models that are best fit to our system? How do we verify and validate that our simulated system is working well? How do we then use statistics to then make estimations of performance coming out of the simulation? How do we use these so-called variance reduction techniques to reduce the amount of time we need to spend doing simulations to get a good result? And then we'll finally close with some more advanced coverage of different types of simulation applications that you might see. We'll have a final exam and it's cumulative. It'll be over all of those units as well as the laboratories, with primarily a focus on the laboratories that used Arena to do stochastic simulation. But so you can imagine that you will see some Arena diagrams on the final exam. And we'll go over that as we get closer to the final exam. The labs have a similar structure. They aren't sort of a one-for-one match, but they are meant to flow in a way that complements the lecture material. So just like the lectures, we start with simulation basics, discrete event system simulation basics. We do a hand simulation exercise, which is very similar to a homework exercise that you will also do based on the lecture content. We do an introduction to different types of simulation methodologies, and then we go into sort of an Arena tutorial. This Arena tutorial is going to start with some basics of Arena, and then we're going to actually make use of the laboratory for you to go out and gather data for your final project, where you'll actually build a model of a real-world system using Arena. And then we'll come back into the lab. You'll learn a few more advanced topics, and then we'll have some open lab time for you to wrap up your final project, and then that will be all of the lab material. The things that you'll need from this class is, for one, a little bit of a background in programming. So we have a prereq of CSE 200 or 205. What we really need is some background in programming where you're comfortable writing, debugging, and executing programs that make use of a significant amount of logic flow, looping, those sorts of constructs. As I said, we'll primarily be using Arena, which does involve some formulas and things like that, but for most of you, it'll be very different than, say, C or C++ or Python or Java that you might be familiar with from other classes or your personal experience. The textbooks you'll need, unfortunately, have to require you to get 2 textbooks, or at least get access to 2 textbooks. There's this classic textbooks by Jerry Banks and others, Discrete Event System Simulation, that's the lecture text. And then there's a laboratory text by Kelton and others. And that laboratory text has gone through a large number of versions. Really, any version after, say, the 4th edition, or maybe even the 3rd edition, will be fine. And you can, if you happen to get access to it, even an electronic access somehow, then you should be able to bring, say, your own laptop into class, or if you have that electronic book in some remotely accessible way, use the computers inside the lab room to access that. So you don't necessarily need a hard copy of these, but you definitely need access to them. There's going to be homeworks and readings that come out of the lecture text, and there's going to be laboratory exercises that come out of the lab text. And as you get to your final project, even though we try to cover a lot in the labs, there's still going to be a lot that we don't cover that Arena can do, and you may need those things to do your final project. Consequently, it's going to be a useful reference to have. To figure out what parts of the lecture book you should be reading, if you go onto Canvas, you'll notice that every lecture in the modules, so here's the Unit A module, has a little bracketed chapter or chapters after it. The expectation is that you'll have read that chapter before the lecture. And we do a few interactive things during the lecture, which may call on the knowledge that you've built from reading that chapter ahead of time. So that's the expectation. So if you go under modules and open up the units and look for the lectures, you should be able to see which chapters are expected before each lecture. Other materials that might be useful come in the software side of things. And so definitely I recommend you getting the Arena student version. It's free. You can download it. There's instructions on the Canvas page on how to download it and install it easily. Unfortunately, it is only a Windows program, but if you have virtualization software on a Mac or on a Linux machine, you can also run it. You can also get access to it in the not only the laboratory for the class, but the general laboratory for all of the SIDC students, and you can even access it via our SIDC virtual lab, although in the past it's been a little slow coming from the virtual lab. Other resources, once you have Arena, there is an international competition that for students at your stage in their career that we highly recommend that you think about entering. There are monetary rewards, and I'll talk about this a little bit in class. But and you can also go to this links to read more about it, and we can actually, in many cases, have you use that experience as part of your final project. And then there's also a lot of resources online. If you go to YouTube and search for Arena tutorials, you'll find tons of them. But at Rockwell's Arena site, arenasimulation.com, they have their own video library, which you can make use of as well. Aside from Arena, I definitely think you should have access to a spreadsheet program like Microsoft Excel, which you can get using your Office 365 membership, or Google Sheets, which is available for free through the Google Apps for Education that the students have access to. You may benefit from having other tools like MATLAB or R or Python or different stats packages. This course makes use of a lot of statistical frameworks that you may have seen before in like IEE475 and maybe IEE475, and so the tools that you were using in those courses may also be useful in this course, although we don't make it necessary for you to use, say, SPSS or SAS or anything like that. We'll give you the ability to do those stats without those, but if you have them, then especially during coming around final project time, it can make things much more smooth. Otherwise, we are going to introduce you to a couple other packages like NetLogo, and so encourage you to check those out. compare them to Arena, and increase the technical skill set in your CV. But they're not going to be required. Any software package like this will have available in the lab, but definitely it won't hurt to have access to these as well. All right, so let's move on to how things are evaluated. So there's 100 percentage points in the class grouped into these different categories. So I do take lecture attendance nominally every class, but sometimes I skip it. And if you look on the Canvas site, you'll find that there is a certain number of lectures that are going to be dropped, or at least low scores will be dropped from the lecture attendance. And so check on the syllabus to find out more about that. How I take attendance, and I'll give more details about this towards the end of this slide deck, is I use these survey questions throughout the lecture at kind of random spots throughout the lecture. Well, I'll ask you a question that I think might be related to the lecture topic, and you can give an answer, and it gets recorded in your attendance response. And these are graded for completion, so validity, but not necessarily correctness. And so that's how you'll earn your attendance point. Of course, they're all individual, but I sometimes will say, well, you can do a think, pair, share and talk with those around you to converge on an answer to these things. I also have these interactive Canvas activities. Again, a certain number of them get dropped. Check on the syllabus to find out more information about that. Those are roughly weekly. What these are there for is they are totally online and auto-graded activities that test you over usually the most recent lecture and the upcoming lecture that you should know about through the reading that was assigned for that lecture. So you'll get a couple of questions on stuff that we've already talked about and a couple of questions on stuff that we are about to talk about in the next lecture, but you've read about it, so you know enough to be able to answer those questions. There are homework assignments about every 2 to 3 weeks. Whereas many of the other things here can't be turned in late, the homework assignments do have a late policy, which I'll go over. There's the midterm. There's only one of them. It's mid-semester, roughly halfway in the class, is what I showed in that outline there. There's a final exam, just the one during finals week. And then there's this final project, where most of that stuff happens during the last week of classes, at least the presentation parts of it. We do take lab attendance. It's just a simple attendance, however the TA wants to do it, but you need to be marked as present at the lab in order to be allowed to upload or to receive credit for any lab report you upload. So you can't just do the labs from remote. We do want you to at least come to the lab so that you have an opportunity to interact with the TA and solve problems that might come up in the software that are going to make it difficult on you in submitting the lab report and difficult on the TAs in grading, and we want to try to get rid of those difficulties by taking care of that ahead of time. The final project that I mentioned, it's 25% of your grade, and that's divvied up in this way. So several weeks, I don't remember in particular, let's say about 5 weeks before the final project is due at the end of the semester, you form your group. That's an individual assignment, but everyone has to submit that assignment so that we're sure that everybody has formed the right group, and there's going to be 4 people in your group all from the same lab section, unless you get very special permission, which is rare. Then there's an input modeling report. Again, we'll learn what input modeling is a little bit in Unit A and then in later units. And so that will be submitted, and it also can be viewed as a sort of a proposal for the project you want to do. Then we'll do a group presentation. That's in the last week of classes. And so you present to your lab, and then you'll get feedback from evaluators who also show up there, like myself, the TAs, and maybe extra faculty from IE. And then you actually get credit for attending everyone else's presentations too. So that way, if people sit through your presentations, if they're kind enough to do that, we want to make sure that you're kind enough to sit through their presentations. And we do see that students learn a lot from seeing how other students handle their lab presentations. And so we do think it's pedagogically important for you to spend time seeing how other people have worked through these problems, and that's why we have that. It's 1% of your total grade is attending others' presentations. And then that after you get the feedback, the Saturday just before finals week, so just after the last week of classes, you'll submit a project report, a group assignment, and that'll be due like Saturday evening. All right, now another just kind of a navigational thing. You'll notice that the homeworks and these interactive Canvas activities have these funny names. And those funny names relate to lectures. And so you'll see that a homework might be called Homework B1. And you'll notice that there's another lecture, Lecture B1. So that identifier that matches there represents when that homework is assigned. So it basically means that you may not even expect homework B1 to be available until the day of lecture B1. And that sort of means that the content covered in lecture B1, by that time, you should have enough background to be able to move forward on the homework, maybe with a little help from the book. On the other hand, the Canvas activities are named for the lecture in which they're due. So an interactive Canvas activity called ACA A2 is going to be due on lecture A2, which means you have to do it before the lecture. Not the day of the lecture, not during the lecture, it's before the lecture. All right, other policy things, and we're almost done here. So late policy, as I mentioned, homeworks are penalized 20% per day late, but everything else can't be turned in late. Your lab reports have to be turned in when they're due. They'll be due basically on the Sunday after the lab. Typically that's when they'll be due. And the lab reports only receive credit if you attended that lab. The final project may not be turned in late as well. The ICAs may not be turned in late. For excused absences, see the syllabus for details, but basically I always need advance notice unless it's medically impossible. And if it is medically impossible, then you have to let me know as soon as you're well enough to let me know. So you can't wait 6 weeks and say, oh, by the way, I missed that particular assignment because I was sick and here's my doctor's note. If you were well enough to come to class during that 6 weeks, then you should have let me know before that. Excused absences for things like religious observances have to be requested at the start of the semester. That's just university policy. So if 6 weeks down the line you tell me that you have to be out of town or you have to be observing a particular holiday in a particular way that prevents you from turning into an assignment, then I may not be able to grant you that allowance, given that you knew about that holiday ahead of time. And so you have to let me know ahead of time, because if it's a case of a lab or something like that, then I may need to make significant arrangements ahead of time. So that's why we require those observances to come in at the start of the semester, basically within the first week of classes, within the first full week of classes. For grade corrections, there is a similar deadline where after we return the work to you, you have 1 week to get back to us to request a grade correction. And it turns out that at ASU, the provost has a policy that if you request the grade be changed for reasons unrelated to the merits of your work on that particular assignment, that's academic misconduct. So if you request that, say, your grade for the course be raised so that you can maintain visa status or scholarship eligibility or to graduate on a particular schedule, none of those things have to do with the merits of the work that you turned in. And consequently, an instructor is obligated to report you to Academic Integrity Office in the Dean's office. And so if you're coming for a grade correction, make sure it's about the merits of the assignment, because if it's about anything else, we're obligated to report you for academic misconduct. For copyrighted material, all materials in this course are copyrighted. You may not redistribute them. You can't upload them, you can't sell them, you can't transfer them in digital or in paper format unless you get the express written consent of the copyright holder, which is usually the instructor. Now, although you own your own notes, and you are certainly free legally to do what you want with them, It is a violation of ASU's academic integrity policy to share your personal notes related to the course with internet websites or other third parties. So while you're in the course and while you're attending ASU, do not sell your notes. Do not post assignments or assignment solutions on online forums. Also related to academic integrity is so-called unapproved collaboration. Unless we specifically say something is a group assignment, then you need to work on it as an individual. Now, that doesn't mean that you can't work together on general studying for the course. But when it comes down to the thing that you submit, then that must reflect your personal understanding. Going to a friend in the class and saying, I didn't quite understand this particular topic from lecture, or the homework mentions this particular topic and I don't quite get it. That's okay to do. But saying to another friend, what answer did you get on this particular homework problem? Can I see how you did that and can I copy that down? That's going too far. So you can't collaborate on these individual assignments. And when you've been granted collaboration, say collaboration within your final project group, you have to keep that collaboration within that group. So don't go out and ask for additional help from other groups or from groups that have taken the class before or anything like that. We do have archives of all of those past submissions from all those other groups, and we have machine learning tools that automatically can find these things. And also, I just remember a lot of those old submissions and those old projects. And so don't try to redo a project that a past group has done before. All right. So during lectures, we're going to see a couple of funny slides. And so we have to know what to do when they come up. And so sometimes during a lecture, you'll see a slide that looks like this. And for the most part, it just allows the instructor or me to ask for questions. Because we've seen that some students don't necessarily want to vocalize their question in public, then what we're trying here is this digital tool that allows students with a cell phone or a mobile device or a laptop in the class to submit a question anonymously, and then that question can be voted on by other students visiting the site. And then I can then view those questions. If I get a chance to view them while during the lecture, I can try to respond to them directly and instantaneously. Otherwise, I can possibly either record a video or post an additional note or message or an announcement on the Canvas site addressing common questions that came up. Or maybe in the next lecture, I'll take some time to address that particular question. So that's what goes on there. You can use that QR code. It'll go to that URL as well. That's what that's all about. So I definitely encourage you to responsibly make use of that tool. The other slide you might see is one that looks something like this. This is the attendance exercise. And so you might see this slide pop up 3, 4, maybe even 5 times during a lecture at different spots. Sometimes we'll slide over them without actually using them. Sometimes we'll pause there. And then I may ask a question that is related to the content. We'll have a little discussion on it. And before we reveal the answer, we'll have you commit an answer that it will not be graded for correctness, but it definitely has to be kind of relevant. And then this, together, all of your answers for that day will end up being what gets you the attendance point. Now again, we're trying to automate this, and so we've created a digital version that allows you to go in and using a Google form, you'll be able to fill out question by question these things. And so you just want to let those accumulate on the Google form until the end of class. And when the final attendance exercise comes up, then when you're done with it, you can hit submit, and that will be your attendance record. And so that Google form, you have to make sure you log in with your ASU login, and then that's what will give your ASU ID attendance points for that particular lecture. And that gets time-stamped, and there's opportunities also for geotagging for that as well. Now, if you don't happen to bring a mobile device or a laptop that allows you to make use of those, then you can also use like a half sheet of paper, and in this little white box here at the bottom here, you can write your ASU Write username in the upper left-hand corner, in my case T. Pavlic, In the upper right-hand corner, write the last 4 digits of your ASU ID number. So if your ASU ID number ends in 5678, you'd write 5678, and then you can put your responses on that card, and then you can turn them into the instructor at the end of class. But we strongly prefer the electronic version if you can. All right, so where to go next? You finished this half-hour slide deck, so the next thing you should do is go to Unit 0 and look at the other activities in there. You'll need to complete those activities with a perfect score in order to unlock all the other course modules. You also should start reading Chapter 1 of the lecture textbook, the Banks textbook, to be prepared for the first lecture, because that's associated with that first lecture. Look for the first ICA assignment to come out in Unit A, which will be due before the corresponding lecture. So if it's ICA A2, then you'll have to have it completed before Lecture A2. And then Lab 1, that lab occurs during Unit A, so make sure that you attend Lab 1, and then you'll meet your TA there and start working on some simulation basics. All right, I'm looking forward to the semester, and I hope you are too. I think you'll find that simulation is a great way to integrate a lot of your other IE course content together, and actually provide you a tool that you'll be able to use in project-based courses like your capstone. And it's also a very marketable tool that I think you'll be able to find make use in industry, perhaps even easier than some more fundamental tools of operations research like linear programming. So hopefully you're looking forward to the class, and hopefully it ends up being very useful for you.